what AndroWish got for new features in the not 962 or 3 days, but in the last year. And one feature is it can now interface the camera built into most devices by interfacing tkl to the Java class of the Android framework, which is called Android Hardware Camera. This is made by capturing images into normal TK photo images, because that's the most universal format you can present in labels or in canvas and what we have operations in order to start and stop a live preview of the camera. What specifically the Android hardware camera framework presents is the facility to use the camera to make higher resolution pictures in JPEG. And this is also interfaced. And the report, when a new image, a preview image is available, is done by sending a virtual event to a top-level window, which in principle allows to use this from more than one thread. Because if you have two threads which both have a top-level widget, both can receive the image capture virtual event. Likewise, the report of the availability of a JPEG snapshot, which is a real photo with, let's say, 5 megapixels, is done by another virtual event which is called picture taking. There are some means to control things of the camera, for example, the size of the preview image or the JPEG quality or things like backlight compensation and so on, but this is depending on the hardware of the device. Okay, so in the next slide you see the minor commands to get all those camera features. They are invoked by Borg camera, close for example, or current, or image to get the latest image which was captured by the Android framework and which is then copied into a TK photo image. Here's a small example. It's a webcam in, let's say, 40 lines of tkl code. This is the initialization. We create a photo image with a known width and height. We open a camera. Camera 0 is normally the back-facing camera. Camera 1 is the front-facing if you have a device with two cameras. Otherwise, it depends. Some devices have only a front camera, then camera number 0 is the front-facing camera. Then we set the preview size to fit the photo image. We set the picture size, which is the size for the JPEG, which comes out for the higher or for the JPEG path of the camera, and we set the JPEG quality. Then we bind to the top level the image capture virtual event in order to read the last acquired image into our TK photo image. We start the camera, we pack the image into a label, we start a socket server because it shall become a real webcam, and I'll show you the result. Wait a minute. I hope it's this one. So this is the preview. So now we should know the IP address of my device, then somebody could connect and take a snapshot. So let's find out the IP address.
You're going to get a lot of lists.
This is the somewhat improved version. So would you like to take a picture of you?
No. Yeah, that works. Cool. That's cool.
Okay, this script I think took about 100 lines, but it's small. Okay. So there's my slide. The request handling, configure the channel to be in binary mode and non-blocking and no buffering. The after is needed in order to have some delay to read and forget the request, the HTTP request. Then I set the channel to blocking, start the camera to take the JPEG picture, not the preview, but the JPEG. If that fails, we are finished. Otherwise, here you see the binding, which then sends the JPEG onto the socket with HTTP header in front of it. And that's the send function. That's it. We unbind the picture taken and send the JPEG data as byte array on the socket, and you receive it in your web browser. And after that, we close the socket and restart the preview mode of the camera. Otherwise, the camera would be idle, and we would not see any further pixels in the preview. So you know the IP address, and we can use the simple demo. Where is it? This one. This is the 30-line webcam. And you see there must be some bug. Still. Once more. Maybe you clicked too fast. So the universality of the photo image can be used to make even fancier things. For example, a retro TV. With speech recognition, by the way. Right? So, to be or not to be. You see, my pronunciation is too bad. So, usine. Okay? Okay, that was the camera. In order to make some useful things with the camera, I found two open source packages which deal with barcode and .matrix code and QR code recognition, and I wrote some TCL wrappers around it. And these allow to have a TK photo image and decode a barcode out of it with using the Z-bar library. There's another one which is made for .matrix code, which is also open source with a liberal license, which is called DMTX. So an older library. So, and the idea is you give the library one reference to a photo image. It takes the photo image and decodes the barcode out of it and returns it as a result, as a string, with some other information, for example, the number of milliseconds for recognition or the kind of symbology which was detected. There's another variant of this decode process which is made in by an asynchronously running thread, where you can overlap the decode with the processing. So let's see the example. The example is in the example section of the AndroWish website. And I can start it by, hopefully by clicking on the right link here. Barcode scanner. Now we need a barcode. So I have to focus on it. And this is made by using the tkpath. You see the alpha blending. This is a p-rect with opacity and the text of the red barcode, plus the type of barcode, plus the number of milliseconds for the decode. Okay. So more on this to be read on the www.androwish.org website. Okay, next feature, emojis. Last year, Jan presented Unicode 8.0, which is since 1 week old, because 9.0 is out. And I found that very interesting and experimented in order to get this Unicode, this full Unicode stuff, working on your Android devices, because you have this fancy emoji keyboard on it. Which you can see here. So the possible solutions to get emojis working with the current tickle is to use TCL UTF max set to 4, not to 3. 3 is the default, or to 6. I chose 6 because it was, for me, easier to code the stuff where it has to be rendered on screen, because FreeType already uses 32-bit representations for the Unicode code points. But maybe the other way around is also possible, but this is not very well tested. So in principle, this enables the syntax with the uppercase U in order to write hexadecimal representations of the full Unicode range. In contrast to the normal lowercase u, where you can only express the basic multilingual page. things we have to talk about are Windows 32 has the problem that the operating system interface has 16-bit Unicode. There's the need to have another step to translate between the 32 bits to the 16-bit WCAR data types when you are on Windows. But this is technically also solvable, as I'll show later. So, the text input you saw already is working in Android. I'll show it on Windows too, but I have no idea how this works on the other platforms, especially X11 and macOS. Another point is that on SDL, also on Win32 and X11, when not XFT is used, the usage of those full Unicode range can be very memory hungry in the current TK implementation. And I have no idea how the TCL UTF-Max 6 compares to TCL UTF-Max 4 in terms of runtime costs. Wait, I have another demo for the emoji stuff. This one. $99 red balloons, by the way. It's a little bit slow because this is an older tablet. So basically the Unicode input in the full range is working on these devices with TK. Okay. So the next step was to make in cooperation with René the things to have tkpath render to PDF. And this was achieved by adding a similar interface like the PostScript print to the tkpath canvas code. There's another function which instead of creating PostScript makes a fragment of PDF and calls into the PDF for EuroTcl implementation which puts all the pieces together. Almost everything now can be rendered to PDF. There are some things unfinished. There's, I think that those aren't often used, repeating gradient fills. But simple gradient fills are working. I'll show it. And a big point to be addressed is the font mapping, because a plain PDF only supports Windows or Latin 1 fonts out of the box. So you have to provide font information plus mapping information if you want to have emojis properly rendered in PDF. And that's, I think it's a bigger task. Okay, there's an example for it. This is the camera, and those are P images in tkpath parlance. And you see some fonts, plus some crosses. if I double click, hopefully a PDF is written. And it's a live image. Okay, now I should have a PDF, and hopefully I can display it now. This should be the current PDF. You see? Let's zoom in. It's a slow device, as you can see. But if you zoom enough, you should see the alpha blending. And the rounded corners. And the anti-aliased pixels. Okay. So I think this was the work of half of a year, and then came another idea, which I called undroidwish, where I put parts of the undroidwish source tree on another platform, Windows and Linux. And I used some technique I used for AndroidWish 2, especially the zip file system, and everything, and SDL HGG free type rendering. Everything else is mainstream, which means controlled by a shell script, configure, make a compiler, GCC native, or the min.w compiler for cross-compiling Windows binaries. But I have nearly all features which I have on AndroidWish, except the specific Borg command, which is really Android framework specific. And in principle, it should be possible to render things exactly, pixel exactly, on a non-Android device. The packaging is done in a final step where extensions are packaged into a zip archive. You see here, this is the tkpath core, statically built, gives about 5 megabytes, and a bunch of extension which gives another 15 megabytes, and everything is self-contained, no installation, nothing. A similar approach, or not quite like Paul had, or like the KBS of René. Okay, so things to consider. Link it statically. Since I have some C++ code involved, basically HGG is C++. I have to look out for dependencies on Linux as well as on Windows. And the good point of HGG is that it can be compiled with a custom memory allocator, where you can completely eliminate new and delete. So I have no dependency on dynamic libstd C++. And therefore I can really say this approach is self-contained. It should run on all Windows platforms since Windows XP with one binary. Similar approach can be chosen for Linux, where the trick is not to use the greatest, latest distro, but an older one. So you can support all Linux boxes which came out in the last 8 years. When there are things in the Linux world, especially things like libudev, or I think another candidate is libusb, which are not available in old Linux, then an approach where runtime linking is made is the best to overcome the limitations on older systems. Okay. This project is documented on the undroidwish.org page. There are ready-made binaries and a little bit of documentation. So now let me start the other PC and to show it. On Windows. Project. This is a Dell Venue 8 with Windows 8.1. And you saw the emoji demo. This should run on Windows too. Takes long to start up. Oh, sorry. Where's the keyboard? Here. Some rockets. Some planes. Okay. So what I also did for the undroidwish is I tried the tkpath, and I found Ashok who did the support for Unicode 8.0 within a week. And the result is here. I took his window inspection toolset, and you see it here in SDL rendering. The Windows program looks like an old motif, but is really using tkpath enabled with Unicode 8.0. With this fancy feature to have the possibility to zoom in to smoothly zoom in, since normally SDL uses OpenGL for the final step of presentation. So switch the devices. This was tkpath. Many thanks to Ashok for his work. He basically built in a new object type which supports the translation between between 32-bit Unicode code points and Windows W charts. Oh, sorry. That's the projector. It won't connect. The device says connected, but we don't see nothing.
Is the Windows device still connected?
No. No. Maybe I should boot it. Ah, here we are. Okay. Based on my experience with the Vogue camera, I decided now it's time to have it on Linux and make a similar interface for video for Linux version 2. This is also available if you build the undroidwish for Linux. And the last thing I did last weekend is the same for Windows, using the Windows Media Foundation, which is I think the third incarnation of live video on Windows since its invention. And it's not compatible with video for Windows, and it's not compatible with DirectShow. So I think Microsoft has to reinvent everything all 8 years or something like this. But I got it somewhat working, and I'll show it finally now. Disconnect.
That's right. It's filled, isn't it?
Disconnect. Connect. Please connect. Ah, here we are. Okay. I'll show you the normal tkl version first. TK, not based on SDL, but on normal GDI cores. Plus Richard's 3D canvas. This is live. This is live, and this device has an Atom 4-core CPU with less than 2 gigahertz. It's amazing. You can zoom in, of course. And it works both in a normal TK environment, as well as in the undroidwish SDL2 rendered environment, which I show now. If it starts up. Okay, it starts. It's amazing reactive if you think that it's a very, very low performant computer here. And it could be a smartphone. And this is tkl. Okay, that's it. Questions?
So you have really made some very impressive packages, and I think like the Zebra barcode decoding stuff and this one, and I think most of them have also used outside of your special built dish version.
Yes.
So it would be really helpful to have something like TIA compliant packages which we can all
They are.
download
You have to pull them out from the androwish.org fossil. But please you do the work, not me. Pull it out. This one should be TR compliant. The barcode stuff maybe it needs some work in the configure. Maybe it needs some adaptation for a specific platform. And the barcode stuff is, I think, easily ported on Linux. When not already done by me, I don't remember. But the step to get it on Windows is more complicated, I think. But possible, definitely. Just use it.
So you have to convert the image 2 times. From the camera you get it as a TK photo, and then you have to put it as an
it's
OpenGL texture.
even worse. on Linux I can get it. First, it depends on the camera. Webcams usually output Y2 format, which is interleaved YUV signal. Most Android devices output NV12. This is otherwise interleaved, but basically YUV. The Windows Video for Linux layer has conversions built in, which makes it simpler. You can get out RGB from Video for Linux, but on Windows you get a plain format. And on some Windows webcams, the newer ones, you get a motion JPEG. Therefore, I have to make conversions. So my first conversion step on Android is to compute the RGB from NV12, as is the case with this device, and then go into the photo image and then go on screen. And maybe I go through, in this case, I have another step where it has to convert it to OpenGL, bitmap, or how it is called.
Texture map.
Texture map. So 4 steps. But the funny thing is, we get a frame rate of 10 images per second here, which are distributed around the cube. And this is a 4-core Atom hardware. Cheap, slow. Okay?
Where's the next way? Okay. So then,
Thank you.
again, Christian.